Hi students, it's Mr. Nguyen here. Today we are going to learn about how to solve quadratic equations by graphing. And the main tool that we are going to be using today is Desmos calculator, okay? So in this lesson, we will learn how to use Desmos graphing calculator or any other graphing technologies that you have, but Desmos is the easiest one, most accessible, and most user-friendly one that you can use. So you're going to be using that to graph your quadratic equations. We're going to identify the x-intercepts of the functions. These are where the solutions are to your equations. And we're also going to determine if an equation has one solution, two solutions, or none, based on how the graph looks. Okay. Our essential question is, how do we determine the solutions of a quadratic equation from its graph? Okay. And like I said, your main tool today is your Desmos graphing calculator. Okay. So let's talk a little bit about the graph itself. The name of the graph is called a parabola. So what is a parabola? Well, a parabola is the graph of any quadratic function. Okay, any quadratic function, its graph is called parabola. Okay, and the graph of the parabola has many, many different characteristics, or I guess we should say features, right? The line that goes straight down that split the graph in half, it's called the axis of symmetry, this vertical line right here. The tip of the graph is called the vertex, okay? And the point where it touches the y-axis are called it's called the y-intercept. And the points where the graph touches the x-axis are known as the x-intercepts, right? So in this case, we have two of them. These are the two most important things that are relevant to our lesson today, okay? So when we're graphing parabola, when we're graphing a quadratic equation, we're going to be looking for the x-intercepts, okay? So those are the locations we're going to be looking for, because these indicate where the solutions are on the of the equation. Okay, so the x-intercepts or solutions are sometimes known as the zeros or the roots of the function, right? So these four different words actually mean the same thing, okay? X-intercepts, solutions, zeros, and roots, they all mean the same thing, okay? So what can a graph tell us about the solutions? Well, the x-intercepts tell us where the solutions are. So sometimes, though, your graph can have you know different looks, right? Sometimes there are two different um, x-intercepts that are shown when you graph an equation. So in this case, of course, your equation has two solutions, okay? But there are other times where your graph only touches the x-intercept at exactly one point. In this case, we know we only have one solution because there is only one x-intercept. And then there is some time when the graph is completely off of the x-axis, like you see in this case, which means the graph doesn't even touch the x-axis. So in this case, we say there are actually no real solutions. There are imaginary solutions that we'll talk about much later on in our math lessons. But for now, just know that there are no real solutions when there are no x-intercepts, okay? All right, let's start out with this first example. There's a link to Desmos graphing calculator here in my lesson if you pull up this presentation. Or you can go to Desmos, or you can Google search Desmos graphing calculator, and the first result is the correct site. So let's say if I were to enter this into my Desmos graphing calculator, the graph will look like this, right? And you can zoom out to see the entire graph if you want to, but really we're interested in these 2 points right here, right? Because those 2 points are where the x-intercepts are. And so you can see the negative, there's a negative answer here, that's negative 44, and there's a zero here, okay? So the graph touches the x-axis at two different places. And so we know that the x-intercepts or solutions or zeros or roots, they all mean the same thing, are negative 44 and 0. Okay. Next example, this is a trinomial. You can type this into your graphing calculator and voila, you're gonna get something like this. And of course, like I said, you can zoom in and out, move your graph around on Desmos. Desmos is the most friendly or the friendliest, I guess, software that you can use to graph. Okay, so here are our two solutions. One is at -4 and the other one is at -3, right? Again, I like to use all four words just so that you guys can remember, okay? X is at -4, X is at -3. So if somebody asks you, what are the roots of this function? You know what they mean, right? They mean to go find the x-intercepts. Or sometimes they say, hey, find the zeros of the function. You know they mean to find the x-intercept because those mean the same thing. They mean the same thing, okay? Here's another one. Okay, so this one is not very friendly, the equation itself, because you can see the x-intercept doesn't touch the grid at a very good location. So they have to approximate this answer. So it's -2.333333. It goes on, right? And this is a zero point 0.5. Okay, so if you use any other method to solve this equation, like factoring, your answer would be exact because you would get like maybe a fraction, right? And this, of course, is a 1/2, right? But for the purpose of graphing, whatever Desmos give you, those will be the solutions, okay? Is there another example? Okay, so here's another example. When they give you the graph and they ask you, hey, what are the x-intercepts? That's pretty easy because the x-intercepts are where the solutions are, right? So it's at x equals 0 and x equals to 4, okay? So this equation has two solutions because you can see there are two x-intercepts. Anyway, that's pretty much it. It's pretty straightforward. It's pretty easy. There, I have a little practice for you guys there just to review over everything that we talked about. So try that practice and let me know if you have any questions. Thank you so much, and please subscribe to my channel. Bye-bye.